Dr. Mohamed Amer is a founder and chief scientific officer at Robust AI, an autonomous mobile robots company for automating warehouse operations. Before Robust AI, he was a senior technical manager at SRI International. That's where we also got the pleasure to work together, where Dr. Amer led DARPA-funded AI and ML programs, including conversational and explainable AI programs. He received his PhD from Oregon State University with a focus on large-scale deployment of machine learning algorithms for computer vision, such as monocular depth estimation, multi-view 3D reconstruction, and activity recognition in large-scale videos. So thank you so much, Mohamed, for joining us today. Looking forward to your talk.
Thank you, Gabriela. Hi, everyone. I think Gabriela did a great job with the intro here, and a little bit additional to that, saying that I'm at first and foremost a scientist. Scientist turned entrepreneur. So there's a new life that I adopted like 3-4 years ago, and this is kind of a talk that talks a little bit more from a science perspective, but also there is a little bit of applications that could be helpful in industry and in applied space. So the talk today is about responsible AI, and we've been hearing this buzzword a lot recently, and it's a very overloaded world. So I decided this talk to kind of walk through what responsible AI is, and from there talk about the challenges that we currently face. From there, we talk about potential mitigations and ways forward to change the state of AI now and in the future, and how to deploy it responsibly. So kind of looking at the timeline for AI, and like starting prior to 2012, prior to the deep learning paper from AlexNet and all the work in 2010 that popped up in 2012, we started getting more traction. AI was literally a bunch of feature engineering and simple classifiers. The focus was only on ML analytics, probabilistic models, and some logic systems existed at the time. And they were very simple, performed poorly on large dimensional data, but actually worked really well when it was small dimensional data or really well feature engineered. If you look at any of the patents that existed prior to that point, every company was very proud of their descriptors. They had the SIFT, SURF descriptors, and the SIFT descriptor, for example, was one of the most used, the most successful descriptors, still is actually, in computer vision, and the patent for that just ran out last year because they didn't find the point of renewing it given the presence of deep learning. I kind of went on Google Trends, and you can see like it's kind of flat-lined machine learning as a search term. Now we move from 2012 to 2018, and then now it's kind of a hype of deep learning, and the focus became, hey, if you have a lot of data, you'll be able to extract the features that will help you with that specific task. So instead of designing the features, let the features be learned. And then feature extraction became free all of a sudden. And then the model learned specific features for the specific task. So instead of having this generic feature extraction phase that can go to any classifier, now you have a different kind of feature extraction that is actually learned for the specific tasks. The tools that were around were kind of, you start seeing TensorFlow, PyTorch popping up around 2015, 2016. And it's kind of commoditizing the space of deep learning and being able to build your favorite network really quickly. And I remember in my first time building a deep learning network was 2010. It was a MATLAB on a janky Lenovo laptop, was one with a GPU that had 1 gig of memory, and it was really difficult. It took me about 6 months to debug the backpropagation algorithm back then, and now you don't even have to do that. You have automatic differentiation. You have all those nice set of tools that actually enable you to build your favorite network without having to worry about screwing up the backpropagation equations or any of that. Then the focus was literally on high-profile research papers. If you look at DeepMind, Microsoft Research, any of the bigger players started actually doing this high-profile research papers, anywhere from, hey, our classification accuracy is now human level, or hey, like we can the computer can play Atari games better than a human, or the chess papers, or so on. So there was a lot of hype in general, and you can see this big ramp up around 2014, 2015 until now, and then it kind of started tapering off a little bit. And this is the stage. I think now there's a lot of focus on new terms. The new term coined MLOps, similar to DevOps. There's machine learning operations, and with a focus on production. Now, okay, we have had the hype. We know what works and what doesn't. We have some idea of how it works in production. But to deploy a machine learning model in production, you really need a lot of other things in place to make it reproducible, scalable. You need to do monitoring and logging of what's going on. You need to continuously fine-tune and refine your data to feed to the machine learning algorithm to give you the results you're looking for, whether it's classification, whether it's runtime requirements. So now the word MLOps started actually popping up kind of late 2019, 2020, and until now, and you'll find a lot of funding going into MLOps and monitoring and logging in that space. So it's more focused on the developer rather than the researcher, whereas the previous step focused on making the research tools or like the development tools for researcher particularly became very commoditized. This time it's focused on the developer that's actually pushing this into production in real systems. So if you look at it, there's kind of a cost-benefit analysis situation where we need to look at here. So finally, AI is bringing a lot of multitude of capabilities, right? However, there is a risk of adoption, and this risk can be anywhere from safety, from bias, from multiple dimensions, and that's kind of the motivation to get to this point of the talk. So what is responsible AI? Responsible AI is kind of, think of it as a guiding principles, a set of principles that developers will agree on. I say developers for now because they are the ones in control. Eventually, it could be developers and governments and regulatory bodies and so on. They agree on to address the ethical and legal challenges of AI. So if you look at that, right now, the AI space is dominated by a handful of for-profit companies. I can count them on one or two hands. And you start seeing governments talking about regulation, safety, especially the EU started pushing hard on AI-driven systems and how they are being deployed and what kind of decision-making they're making, and especially when it comes to things that affect people in their daily life, whether it's machine learning algorithm analyzing your bank loan application, or whether it's the automatic decision systems in New York, for example, in New York City, in multiple ways it's being deployed. You can actually look at the AI Now Institute. They wrote a really nice report on, in-depth report on the New York City automatic decision-making systems. And you realize that at the end of the day, the systems are actually brittle. And they got more brittle once deep learning became a part of the picture, because now you don't know what features that the model is fixating on, and the decision-making became a little bit more opaque. So that could lead to real-world disasters. And if you look at the current guidance for responsible AI, and you have some publics, the FTC, for example, gives us 6-7 bullets of, hey, start with the right foundation, watch for discriminatory outcomes, embrace the transparency and independence, and so on and so forth. Tell the truth about how you use your data, do more good than harm, hold yourself accountable. If you look at all of that, that's literally guidance. That's not standards, that's not compliance, that's just guidance, like, hey, be nice. Okay, sure. Then you look at the private companies, Google, for example, has this on their website of AI should and AI shouldn't. And again, it's a should or shouldn't. It's not must or mustn't, or it's not regulated by a bigger body. And if you look at what happened at Google and their ethics team, that's a whole different story to be told there. So right now, everything is, hey, do good, be socially beneficial, avoid creating and reinforcing bias. But how do you evaluate all of that? How do you actually enforce all of that? It's not clear right now. And there is this AI incident database. If you look it up, there's a lot of irresponsible AI, from autonomous vehicles killing pedestrians to translation errors leading to people's arrest, to a lot of bias allegations, whether they're true or not. I think they are true, and so on and so forth. So you can look there. There's at least now it's probably 2,500 reports the last time I looked. So the question becomes on governance. Who's actually managing this governance chain, and who is kind of making sure that whatever companies or entities are doing with AI is regulated, and what does governance look like? So the models are getting larger, more complex, require extensive engineering, and the data is full of bias and full of its own issues. And the current stakeholders are big players in the industry and the governments. And the models are governed by the developers right now. And eventually, policy might kick in, but that's still in the works. That's not kicked in yet. So if you look at it, you have the data, the security over the data, the cost and value of that. And then you have the bias coming from the data, accountability, an audit trail, and then the available time for evaluation of those systems. So if we continue on, right now you have this big hype of generative AI, and I'm sure everyone heard about Stable Diffusion and Stability AI, and they're trying to be a consortium of, hey, those are all different dimensions that we would like to push on the generative AI front, whether it's the Dream Studio, which everyone's seen the pictures generated from it, whether it's text generation, whether it's protein unfolding, and so on and so forth. So they are Stability AI is pushing on all those 8 dimensions, and it's a consortium of multiple companies that are actually aligning together to have an open AI version for all those different dimensions. And then this article was literally from a couple of weeks back about who should control generative AI. And if you think of generative AI, it's a can of worms, because once you start generating photorealistic images, imagine all the wrong ways this could be used. Once you start generating text, imagine all the ways that this could lead to misinformation, disinformation, and so on. So it's getting worse. It's not getting easier, because now if this is all open and there's unregulated copies of those pieces of code, and you can go on Hugging Face and try your favorite. Stability has their code up there. DALL-E is there. GPT-3 is there. Illusor's model is also there. So you'll find all of those models. They're accessible. You can have the open source code for them to actually do whatever you need to do. Now that it's accessible to everyone, the problem gets bigger. And if you look at it, at the bottom of this story is foundation models. And foundation models were supposed to be initially like those big deep learning models that you can pretty much, a big company can train, because they require a lot of infrastructure, a lot of compute, a lot of data access. And I think someone did analysis on GPT-3, and just to train a GPT-3 model costs anywhere between $250,000 to $1 million in compute resources. So only big companies can produce it, can regulate it. And now smaller players can go and do fine tuning, do specific tasks being pushed out of those foundation models. And it started off with OpenAI, the company, and they started with GPT-3 and then DALL-E, and then the knockoffs started kicking in, and other forms that are even better than what they're doing. But except that OpenAI had everything behind a closed API, so no one had the source code, and they were actually doing a lot of work on alignment, on safety. They would not allow anyone to proceed with applications without having a review from OpenAI, and this is the guidelines that they provided at the time. They literally controlled the API to an extent that to make sure that it's safe, to make sure that it's not causing harm. And now there is an open source version of all these different variations of OpenAI models that are now circulating, and people are using in many different ways. So this is not the case. There is no control from the developer. It's kind of the developer is losing control, and now it's open source and accessible, and people can do whatever they want with it. There is another version from Google, from DeepMind, and they actually outline different risks, anywhere from discrimination, toxicity, misinformation harm, malicious use, and interaction harms, and so on. And they actually specify it in the paper, which is great. But again, it's not controlled now. It's open source. Now everyone have access to it, and they can use it however they want to use it. So the problem is that while foundation models are very powerful, they can fail expectedly, harbor bias, poorly understood, They're expensive. Again, not everyone can produce a foundation model. Usually big companies or eventually governments as well can build it, usually hidden behind an API. That's not the case anymore. And pretty much it's people are at the mercy of those tasks trained on top of foundation models. And the problem is that they're being deployed at scale and accessible. So a version of this, the regulator is trying to come in and do something about this opaque deep learning systems. If you look at the DMV approved Cruise and Waymo to operate here in California and San Francisco, and I actually took a ride with Cruise and with Waymo, and it's pretty interesting. So they're allowed to operate, but then the DMV gives them some guidelines. It's like, hey, the vehicles are approved to operate in public roads between 10 p.m. and 6 a.m. Maximum speed 30 miles an hour in light fog and light rain. And on top of that, what you need to do as a company is that you need to certify that you have done testing and validations on those autonomous vehicles. So now they're giving the evaluation to the developers. Hey, you develop it, you evaluate it, put $5 million bond and for insurance purposes, and you're good to go. And if an accident happens, you go against the bond and probably will reduce your operations and probably will halt your operations. And if it doesn't happen, then just keep going until it happens. So I find that a step towards something unknown. I find it a step where the regulators are grappling to actually find a way to regulate, to put some constraints. However, if the companies are large enough, it becomes really different picture. And it becomes a context of which it's still the Wild West. It's still do what you need to do, figure it out later, and you evaluate, you deploy, you evaluate, and tell us what's working and what's not. And I find that very problematic. And a version of that, you can look at what Amazon did. There is a whole report by Reveal News, and literally they go warehouse by warehouse, show you each warehouse that has automation, and automation in this case is mobile robots or even conveyor belts with IoT sensor to keep the conveyor belt going for packing and so on. And if you look at it, the order of magnitude of accidents increased dramatically in warehouses with robots, and that's what's reported by Amazon. The reality might actually be a lot different than that, since they have also clinics on premises and so on too. So not every incident is actually reported. So this is out of all the reported, you can see this order of magnitude higher number of injuries. And it's usually happening around the holidays, right? The holiday season, the Christmas, between Christmas and Black Friday and all that period.
Do you also have numbers on injuries before robots were used in similar? So is there a significant increase without the robots? Because I don't see the numbers. So those are with robots in 2000.
So without robot is the lighter color, with robot is the darker color here. And I compiled this actually based on literally analyzing a big spreadsheet that I can point you to, Gabriela, if you're interested, of each warehouse. They tagged it automated with robot, without robot. And the number of incident per 100 workers literally is an order of magnitude higher.
Got it. Yeah. Interesting. Thank you.
Of course. So there are multiple ways to actually evaluate those systems. And there is some work starting, at least in autonomous mobile robot, there is some work starting in autonomous vehicles. There's less work in the generative AI space. I know for a fact that OpenAI is working on standards for DALL-E and for GPT-3 that they have not yet released, but they're trying to actually set the standards there. And pretty much the standards try to provide a guideline of how to evaluate the system. So in a robotics setup, there is R1508 Industrial Mobile Robot Safety Standard that just was for mobile robot. It started actually in 2020 or 2019. It's not long ago, but also it's still kind of not really clear. If you look through the standard, they tell you, okay, well, do some risk assessment, do some risk reduction at design stage, which I can talk a little bit of how we mitigated that at Robust for our robots. And then there is some risk measures during deployment, but then a part of it is supervision, a part of it is marking on the floor, a part of it is kind of marking the environment in a way that allows the people to be out of the way of the robots. And this is a moment where I kind of pause a little bit and talk about Robust. And what we did at Robust pretty much is human-centric design on how the person interacts with the robot. We started with the person rather than starting with the robot. And the idea became, hey, mobile robots are very intimidating in general. If you look at them, it's usually this puck-shaped or like rectangular shaped cart that is on the ground. It has a big red button. If something bad happens, you need to hit that red button. It's called an e-stop. And if you manage to catch the robot, so imagine a robot moving, it's doing something, it's maybe harming someone, and you need to run after the robot to hit that red button to stop the robot. So that's even like insane to think about it. And when you look at places where those robots are deployed, if it's fully automated, it's only a robot environment, that's fine. The problems can happen, but it's robots against robots, so they will deal with it. It's not people's problem. But once you have warehouses where you have this collaborative robotics, and you have people and robots coexisting in the environment, that's when problem starts emerging and becoming more of a safety concern. And then on top of all of that, if you think about it, the robots themselves are not designed to be in a context of humans. They actually started with the robot in the form that was running in, for example, Kiva at Amazon, where it's all fully robotics environment, and then tried to do some perception to allow those robots to operate around people. And instead at Robust, for example, we ended up focusing a lot on safety, focusing a lot on the human experience. So instead of that e-stop only, we actually have our robot looks literally like a shopping cart, where if you touch the handle of that robot, it moves from being a fully autonomous robot to a power tool, a powered cart. So imagine like the ability to just, if something is going off, you can literally treat it as if it's a cart that's running from you down the aisle, and it will stop and it will now be a power tool. All the sensors around the robot, we put about 30-ish, 30 plus sensors, cameras around the robots. So we have full situational awareness. And on top of all of that, if the robot detects a person in front of it or on the sides or anywhere, it actually will not move in that direction, even if it's being pushed. It will apply brakes. So we started from that dimension, and that's the first part here, risk reduction measures taken during design. But that's because the company consciously chosen to do that. If the company didn't, then this part becomes, okay, well, you have a big red button to hit in case of a problem. And the standards do not particularly enforce that. They do best practices and suggestions. Not all industries, not all verticals require you to be compliant with those standards at deployment time. For warehouse, you have to be compliant, but it's now self-administered. So we evaluate ourselves as a robot developer company and then go into the warehouses with our robots and say, hey, by the way, we are compliant with R1508, which I don't think is sufficient. So right now, policy is lagging behind, and it's becoming reactive rather than proactive. And if you look at it, the EU's setup, this article is from a year ago, and it's still not enacted yet. So they're pretty much saying that the AI fines will be about 6% of total gross revenue of companies. So they're trying to hurt them on the money. If you have an incident, if you have issues, if you don't have ways to audit your systems, you'll actually have to start paying money out of your gross revenue. And then the US is kind of trying to also tread in the same direction. That was from November a year ago, November 10th a year ago. I haven't seen much movement there actually. So again, there is a lag. There is a lot of deployments happening, and there needs to be some way, systematic way of actually dealing with AI and evaluating AI. And what we end up with here is lack of policy guidance. Corporates are doing whatever they do to increase their bottom line, and the fact that the AI is not safe kind of comes as a second component, second thing to think about. A lack of responsible AI standards or ways to audit them. Companies deploy their machine learning or AI is beta software to avoid liability, and that's in the case of Tesla. FSD is beta software, and if an accident happened, the liability falls on the drivers that activated the beta software. And models are trained, especially in the generative AI, and scrape data. So you don't know what kind of disasters they've been exposed to that can actually propagate into the inference loop. And the evaluation and auditing are not common, and sometimes are biased or shut down. And in this kind of part of the talk, I'll talk a little bit more about ways forward. Those are my own opinions about ways forward. There are probably better and other ways forward that could be out there. But if you actually look at the space right now, there's a lot of companies, the companies that focus in AI and ML, anywhere from infrastructure support to analytics to machine learning platforms to applications, enterprise to data lakes, to data sources, APIs to support all of that. And literally there is a lot of funding that was poured into that space and continues to be poured in that space right now. However, there is no solution for auditing. So everything is focused on the development side of the story, but nothing on the deployment side of the story to that extent. If you think about it as something like Datadog. Datadog is an application monitoring, performance monitoring tool. But is there something that audits that application? Is it only about performance, or is it also about biases? It's also about the risk component of it. And if you look at the companies that are currently starting to exist in the space, I kind of partitioned it into 3 different dimensions of measure, mitigate, and ensure. I'll talk a little bit about insurance in context of responsible AI in a minute. So on the measuring tools, those are companies that started emerging, probably 3-year-old, the oldest one of them, that are really focused on monitoring, logging, and evaluation, but not particularly deep on evaluation. Only Gantry, I would say, is the only one that has more focus on an emphasis on evaluation, and the rest are more monitoring and logging and understanding of the system. Credo AI focuses on responsible AI evaluation of systems and mostly focused on enterprise use cases of tabular data. So think of it about accounting or analytics and accounting irregularities, or cybersecurity, or even different forms of bias that can exist in automatic decision systems. Fiddler and Y Labs focus on explainability particularly, and Anthropic is still unknown exactly what they're going to be doing, but they're focused on the alignment problem. Then you have mitigation tools, and usually they are produced by large players or mitigation services, all the consulting services that exist out there. And then finally, insurance. And everyone will probably scratch their head, what is insurance doing in the picture of responsible AI? So what's happening is that reinsurers, which are the insurance companies that insure insurers, it's an interesting concept of the layering of insurance, reinsurers. And reinsurers right now are looking at how to insure AI-driven products. And they require a level of monitoring and logging to be able to do claim settlement. They require a level of performance evaluation, which area in the ROC curve that you're actually operating at, and what kind of performance are you providing in this version of the system. And if you provide all of that, they're willing to write 2 types of cover: loss of revenue cover, and the other one is liability cover. Meaning that if I tell you, hey, use our robust AI robots and they'll give you 3x yield and no one will be hurt in your warehouse, and you come back with like, oh, Mohamed, you're just a good salesman. Like, what will end up happening is those robots will be parked in aisles and no one's going to be using them, or they're actually going to be harming people in our warehouse and we'll end up with a lot of lawsuits. So it's like, hey, no, actually, we've worked with Munich Re or with Swiss Re or one of those insurers, and we provide them tools to measure and evaluate our system, to log and monitoring the system constantly if needed. And on top of all of that, we're compliant with those standards, and that was evaluated. And they're willing to write an insurance policy for loss of revenue if I'm not delivering the performance I said I will, or liability. The point is, in a robotic system, it's still complicated. That doesn't exist yet. But in the context of other cloud applications, that does exist. I encourage you to look at Munich Re's case studies. I think their division is called AI Sure, and take a look at the 5 case studies that they have there, from toxic content classification to infrastructure analytics. All of those are AI-driven products that they actually write cover for. So the question is why auditing and insurance? So first of all, if you have a way to audit a system, whether it's an internal audit, whether it's an external audit, like first, second, third-party audits, you'll actually be able to evaluate what the system is doing, what is currently happening on the performance space, on the responsible AI space with bias, safety, and so on. And by having that ability to audit, you'll actually be able to understand more about the system. And if you think about that picture, for example, Underwriter's Laboratory, if you look at any of your electronic devices charger, you'll find UL on it. And UL literally made electricity safe in the 1800s, right? They were literally auditing chargers because electricity was causing a lot of fires, right? And so on. And think of something like that would exist now, that would actually make AI safe. Can we actually have an entity that helps audit and evaluate systems as a third party? It doesn't have to be one entity, it could be multiple entities. And then the second part is insurance. Are insurers able to, given that you now audited your system, are they able to, or your system is auditable, are they able to write cover given that information? So now by having auditing, you can lead that to insurance. And by having auditing and insurance kind of pairing, you can actually go towards an alignment of incentives where the developer wants to do better because their systems now have to be paid premium insurance premiums on. And if they're not as safe and not as performative, then they will probably have to pay more higher premiums. So there's kind of alignment and incentives there. And if they're doing better, their premiums go down. And if you have less incidents, your premiums go down. So think about that as a way to align incentives between developers and deployment particularly. And if you look at it, as 2 sides of the story, the users can trust the audit results since the insurance aligns its incentives, and the developer can sell more products because right now they have a direct financial incentive to make it safer. And the question is how to get there. So we need a new set of vertically integrated process tooling. We need a lot of measuring and mitigation, monitoring and logging tools and mitigation tools, and provide enough information to be able to ensure those systems. So I try to divide that into 3 different dimensions here. One focuses on the data itself, one focuses on the model and model development itself, and one focuses on the system as a whole. Those are the kind of 3 different dimensions that I think there's opportunity for improvement. So first, there are some tooling that need to exist around data curation, inspection, and analysis in general. Being able to detect bias, being able to detect vulnerabilities in the data itself, and understand what's going on there. Then an ever-growing evaluation benchmarks. So not only data for training, but also there is evaluation benchmarks, whether it's collecting all the real data from incidents. If incidents do happen in a certain dimension, in a certain domain, collect this actual data and use it as evaluation data to see if those systems would fail in the future again. Add them to your CI/CD pipeline. Some people are focused right now on procedurally generating synthetic data. And this is a way to also stress test the system by getting this endless amounts of data. Well, there is bias in synthetic data, and we can talk about the biases there, but at least you can bias the data in ways that you would want to stress test the system. And kind of designing simulated environments to generate data with varying complexities, and kind of benefit from the whole development in game engines and all the nerf and reconstructed environments to actually do that. And there are actually a couple of companies that are doing that right now in the AV space. One is Wabi and Wave. They're both focused on generating simulated environments to train their autonomous vehicles and also evaluate their autonomous vehicles by generating, perturbing those environments in ways that the system has never seen before and finding where it fails. And those are the areas where they try to focus on. On the model front, we need to be able to understand the effect of batches of data on the training of the model itself. So can we actually find the instances of the data that caused the model to be trained in certain ways to be able to that cause that inference to happen. So think of it as, can we parameterize the mini batches going into a deep learning training? Can we do actually any form of model certification, verifiability, and explainability? Think of it how you actually verify a software program away from the fact that it's machine learning or not. Can we actually do that for machine learning programs now, since the software is a little bit different in this context? We need a lot of models, model introspection tools, black box and glass box when you actually see the code or when it's actually closed source. And the ability to have adversarial prompts enabling non-developers, think of it as the auditors, to stress test these models. And finally, when it comes to the system, when you have a full system that has a lot of components, we need the ability to have tools to help us with investigating the system. You need to monitor and log every event, every log, every single thing that comes out of the system, whether it's machine learning model generated or it's an inference of a machine learning model that went into another component of the system that could cause that failure. Can we have a way to do automated assurance monitoring? Verify the machine learning and AI systems using tools similar to what is currently available in software systems. And having monitoring and logging be a norm that you have to actually have, including replays, full replays of the session. So can we recreate the full session again, step by step, event by event, and be able to find out the point where things started failing? And potentially go all the way to certified simulators for evaluating systems under certain operating conditions. So with that, I'll pause here and tell you a little bit of why I couldn't make it in person today. Is that I started a new company that's literally focused on this problem, and I'm in the process of closing my fundraising for this company. So things were in flux a little bit with the markets and everything, but I finally received a term sheet and progressing towards closing the round for the new company that's still in stealth, that's focused on this problem. With that, I'll pause here a little bit, take questions, and we can have a little bit of discussion time.
What a great way to end it. Congratulations, Mohamed.
Thank you.
Congratulations. That's awesome. Yeah. Well, it's an interesting take to it. The fact that now cyber insurance is taking off as a market, this is an interesting path for AI, and I think there are not that many companies out there that are doing this. So this is a great time.
Oh, absolutely. It's just been a difficult time to fundraise right now, given how public and private markets and fundraising has been a slog. But I was glad that it came to a conclusion last Friday, and now it's just a bunch of lawyers and accountants and stuff that's spinning up that I have to deal with as well. Yeah.
Sounds good.
Well, question.
Sure.
So we just were having this discussion 2 days back with a lab, like, the challenge of the current AI systems, like, do we rely on these systems to help us make certain decisions, right? In a sense, we are trying to emulate a lot of human intelligence into these machines. And when we try to do that, we are trying to incorporate a lot of biases or things that we see that humans are not great at also into these machines, right? So the biases are coming in inherently in some form into these models. So there were two sides to this argument as to, should we completely let the AI decide, like in your case, right? To what level do I fully trust this AI system to make this right decision for me? Because it might be inherently limited in certain ways. And having human in the loop, or thinking that, somehow human can course correct it in that decision process also may have its own challenges. So what do you think about this conundrum we are in?
I think we need still human in the loop in some form. I think one needs to figure out how to best use the human intelligence in this loop. So in the context of robotics, for example, I'm going to talk about the context we're in. The most successful robotics companies, and I don't we're not at the scale of which I consider Robust as a successful robotics company. We're still developing. We're a Series A. We're still far away from that claim. But one of the most successful robotics companies, their biggest investment is in command centers that can take over in the case of the long tail.
Right.
If a problem happens, and then the key becomes how can you detect the problem early enough? How can you get the SREs, the application engineers, alerted early enough so when the problem happens, they can intervene, whether they teleoperate it, whether they patch it before it happens, and then be able to continue on operation. And using those instances to now know those are problems that happen and try to mitigate them. And the longer you are able to operate, deploy and operate, and have human in the loop, the more likely you're going to collect enough data and enough information through your command center, not actually the developer's loop yet, to be able to influence and inform the developer loop to say, hey, those are the areas where it fails. What can we do about it? And then the next release, we now observe it again, and maybe other problems will occur. But I think some hand-holding is really still necessary in the context of fully autonomous systems. And I think it was a month ago, I was at the Tesla AI Day, and everyone probably saw the recording, but around the hall, there were all the tools, the internal tools at Tesla. Each booth told a very different story there. And if you look at Tesla as a company, even their success and failures, but their success is actually because they have enough internal tooling to help them with alerts. Every time you engage autopilot, it actually does a full check on calibration of the cameras. If one camera is out of calibration, it will not engage autopilot. They have all those tools for augmenting the data sets, all of those tools to stress test the system. Even with all of that, the company is not still able to deploy because the problem is very big and the domain of perturbations is very big. So I think some level of human in the loop is necessary, and figuring out how to use that human in the best way possible to assist the AI system to get better. It's not going to be perfect, but
Right.
it'll get better and it will fail less.
Yeah, because a lot of things I feel are still reactive as opposed to proactive in this context, because we are learning as we are going. And I'm sure these systems will get better over time. But the challenge is, like, when you are designing, in spite of taking humans in the loop in this building process and having better policies, a lot of times we might not perhaps as a designer or at the beginning, you might not think of all the potential use cases the system that you're developing today might have.
Yeah.
That's been a challenge, I think, some of the things, like even with the stable diffusion models that you're talking about, or some of the other ones, I think there are a lot of other ethical questions. So it's a huge challenge, like you said.
Yeah, absolutely. I think if you're at least making the effort from day one, from when you start developing and designing on how the human will intervene in the case of failures.
Mm-hmm.
It's very different than waiting until you build the thing and then say, now we need to figure out how we intervene, how we debug, how we evaluate.
Right.
If you actually have that, and that's what we try to do at Robust AI. From the design stage, how can we think of the human? How would the human interact with the thing that we're building in case of failure, in case of overrides, right? And you actually learn a lot from those interactions, from those touch points. What we end up learning is that, oh, when people go and grab the robot's handle and operate it, we learn from that. What actually happened here, and what can we be informed to inform the fully autonomous system? You have also the concept of shadow deployments, right? Like what Tesla also does is that they have shadow deployments. And then when you have two systems kind of running with kind of orthogonal redundancy, now when they differ in decision, those are moments where you actually start looking at. So by deploying a shadow deployment, you're actually setting it up in a way to give you some alerts as a developer to tell you those are the points where you need to actually look at.
Right. I come from a chip designer world, so I see a lot of parallels in this design process. So there is a lot to probably learn from that community and that design process.
Absolutely.
Yeah.
And actually, it's something just from our past, Gabriela, all the DARPA funding we applied for in our past, DARPA and defense agencies are now looking at this problem. There was actually a couple of DARPA programs earlier in the summer that that literally focus on how do you evaluate, how do you monitor, how do you deploy, and there are components that are coming up around policy as code. How can you actually define your policy as code to evaluate systems? And there are a few of those coming up. So if you guys are interested, I'm happy to look into fundraising through non-dilutive capital, which is government grants. Yeah,
That would be a good idea. Yeah.
absolutely.
So about this new approach and companies. So there are companies out there that are doing cyber insurance, and they are not doing the insurance part, that they are also looking into mechanisms that protect the users. Is that your no? Okay, that could be yet another one.
Yeah. Right now, I'm focused on, I call the space perception to X, where X could be a control for navigation, or X could be a voice assistant, or X could be an alert trigger. So I focus on perceptual systems that have physical components in the world, not particularly systems that are cloud only or something like that. So
Thank you.
I guess I have a question. Can you hear me?
yeah.
Hi. So I do not have the strongest background in AI and ML, but I think about vulnerability a lot. So I recognize that using your system to better audit the current state of a system helps gain faster insights, far faster than a human would. However, I can't help but feel like every edition of software kind of also adds a new surface vulnerability that can potentially be leveraged to perform something that you didn't intend.
Yep.
So I remember you mentioned these topics of redundancy and also synthetic data. So first question is this really an issue for you, this vulnerability surface? And secondly, how would you approach it?
That's a great question. So there are two ways to think about this in context of what I'm doing right now. One is what I call a post-mission analysis. So you deploy your system and you gather a lot of logs, sensor logs, system logs, and you start analyzing that post-mission. The problem in context of robotics, for example, is that you're logging about 30 gigs of data from one session per robot, for example, in a context of a specific task or a vertical. Now, no one's looking at those logs. No one is looking at those logs unless there is a problem. Once there is an incident, now let's go and look at the logs. And now to dive through the logs is literally dumpster diving. You don't know what you're looking for. You're going to have to parse all of this stuff if it's not too obvious. So one thing is, can we actually do log analytics? Literally just dump your logs here. We're going to make it easy to visualize. We can use causal graphs to understand those things happen in normal sessions, those things happened in the non-abnormal session, and try to actually understand more and correlate those things. So now I'm setting up alerts. If you're progressing towards a failure case, I'm going to give you an alert to tell you, hey, you're progressing towards a failure case with a probability of X. I'm not definitively telling you that you're going there. I'm going to tell you that you're progressing towards this failure case or vulnerability with this probability, and this probability is increasing given the sequence of events that we've been observing from your system, from your inference loops that are happening on the system. So in a way, I'm providing that assistance. I'm not being assertive about it. That's just probabilistic measure. All I need to do is now the SREs that are asleep at 4 a.m. need to start waking up. So the alert goes to the SREs like, hey, wake up, there might be something happening. And part of the story I would tell, actually, I was in my first cruise ride, the cruise vehicle, autonomous vehicle ride here. It failed. I was in the car. Someone tried to teleoperate it. They failed. Then they sent two guys in their car to drive this one away and then asked me to hail another car or pay my taxi home. So the fact that they already had those intervention pieces, but the delta time from the car stopping to the SREs arriving was half an hour. So if they had something along the lines of, hey, this is increasing, failure is coming, can you actually make them arrive there in 5 minutes? So your downtime is less, your reputation is more protected as a company. Then the second part is increase of the surface of potential problems by adding additional software. Well, I'm not adding additional software in the loop of operation. It's more on the parallel to that. I'm monitoring, I'm logging, I'm analyzing, I'm providing alerts, I'm providing tools to be able to audit, to understand, to alert. So the worst thing that I could do in my context, and maybe there are worse things that I haven't thought about here, is literally give you some false alarms, additional false alarms. And I don't see that as the end of the world to have additional false alarms, and maybe we can tweak that along the way. The worst case is actually not to provide alerts in the case when things are actually bad happening. But guess what? Those would have happened anyway without me. So what I'm trying to do is kind of bring that delta of failures, reduce it a little bit, and also provide ways to evaluate those systems and audit them, and also provide ways for the insurance companies to be able to say, hey, given everything we've seen, we can adjust your premiums. Given everything we've seen, you can go out to the door as a startup and actually deploy earlier than you thought you would be able to. I hope I answered your questions, but I'm happy to dive further if you'd like.
You did. Thank you so much. And you mentioned your first topic about reducing that delta between even maybe some threshold or even just like the incline of an incident possibly happening and response to that possibility of an event is something that I can see being translated to yeah, I guess a project that Sandy is working on, which is being able to assess the state of a system and really gauge if a cyber event may be happening and hopefully reduce that response time.
Exactly. Excellent. I don't know how much time we have left for more questions, but I'm happy to take a couple more.
I have one, if until other people. So you've been giving a lot of examples from Europe. Europe is known for stronger regulations and so forth. So what do you think will be the next step in the US in terms of regulations with respect to AI?
It's a difficult one. It's a difficult question that you're saying. So I can only speculate in this context, but in the context of the US, I think there's the Algorithmic Accountability Act. I think that was Cory Booker that was leading that effort. I don't know where it landed right now. In the context of the US, there is the AI Now Institute. They were part of NYU. They really are digging deep into different case studies and trying to be in the lobbying space and the Congress space. And I think there needed more institutes like AI Now that is actually going all the way to policy and to educate policymakers. And I think I don't anticipate the drive to be from the US. Particularly, I think the drive will happen from Europe in this context, and the US will end up borrowing a page of the chapter over there and then putting it on steroids. So it's like, okay, now you guys figured this part out, and there's even I like the fact that it's actually 6% penalty on your gross revenue, because that's when you get people's attention. It's like, hey, I'm going to cut into your gross margins, actually. So once you start actually going to the big company and saying, hey, if you're not auditable, if you're not following best practices, and if you don't have ways to protect your users, you're going to pay 6%. So think of those big companies with billions of dollars of revenue. That's a lot of money. And once you start hitting on the money, then people will start lining up. And I don't know if it's correlated or not, but if you look at Vodafone announced this big announcement partnership with Google Vertex AI. And Vertex AI is pretty much a new product of Google that focuses on I don't know exactly what it's focusing on, but it's this is very, very opaque, and what they have online is very little there. But pretty much Vodafone partnered a big partnership with Google Vertex AI to have a platform to enable them to monitor, log, and understand their cloud businesses and cloud AI that they're using at Vodafone. And that is an interesting move, because Vodafone is a European company, and they're partnering, setting up infrastructure to be auditable, to be able to understand what their AI systems are doing, because if they don't have that, hey, 6% of Vodafone's revenue is like a big chunk of money. So I think the drive will come from Europe, and the US will follow suit in this context, because I think from regulation standpoint, Europe is happy on regulation land. The US is less trigger happy on that front. So that would be my guess.
Thank you.
Of course.
Perhaps this is the most challenging one, right? To set the policy is quite difficult on how you identify, because by the time you write down a policy, things are changing so quickly in terms of how it is applied and what context it is deployed. So yeah.
It's super challenging, but I think there are even baby steps we can do on that dimension that get us started to think about it. I think the fact that it's not even on the minds of many AI companies that are using AI in context of which can harm people, that's the problem. And I think start with awareness, and then from awareness to start with mechanisms, and even if it's process tooling, like it could be something simple. It doesn't have to be something too complex at the beginning, all the way to policy as code. Let's now code those policies and put them as a way to evaluate systems. I think it's all relative. It's all small deltas that gets us on the direction that we need to be going on.
Yeah, it's a great point.
Excellent. Well, thank you for having me today. I really appreciate you taking. Oh, one more question coming up. Okay.
Yeah.
I did have one more question. It had to do with regards to the regulations in Europe. Often, when I was at Sandia, ISO quality practices. Do you see that being employed more with the AI companies now? And is that a proactive measure to start up?
Yes, and yes. So, for example, the standard I was talking about in context of robotics, autonomous mobile robots, R1508 is not yet ISO ratified, but they're actually progressing towards that. I feel like having standards is the first step to be able to match audits against what are we looking at here. And for example, if you look at the Underwriters Laboratories did a collaboration with Edge Case Research and did a UL 4600. That's a standard for autonomous vehicles. My favorite standards are actually the defense and space standards, because they are actually quite advanced compared to the commercial land, and they're actually more informative and more well thought out compared to the UL 4600 or R1508. So I absolutely agree that having standards and having some ISO ratified standards will definitely help as a first step towards building on top of it audits, towards building on top of it insurance. So that kind of a trajectory that I definitely agree is one of the right ways.
Oh, thank you.
Okay. Thank you so much, Mohamed. Great seeing you. And again, congratulations on the second opportunity to have fun.
Thank you. Thank you for having me. I really appreciate you having me as a part of your symposium here. And maybe next time we'll be in person. And
Yeah.
I look forward to it.
I would love to have you. Thank you.
Cheers.
Have a great weekend.
Thank you, you too.
Bye.
Bye-bye.